Okay, so this is the first Engineering X meeting. It's like a little info session. As you can tell, what this project entails is building an obstacle course, something similar to this, obviously not to the same extent. So the purpose or the objective of this project is to basically test your classroom knowledge of structural design, more specifically, and apply that to creating a 100-foot long obstacle course with varying tasks in between it. The maximum height of an obstacle is 10 feet, and when you design it, you have to be able to prove that it can support 400 pounds. So this will be a team effort to design the obstacle course, and then you have the option of physically building it, which is very interesting. And when you physically build it, you will have your team actually race it. So 4 people will race it. It's a relay style. So 4 people on each team, and one at a time you race it. And also the total cost of the project to construct it has to be $500 or less. So that's material, connections, all that good stuff. And that's something that you have to provide in the design report as well. The only participants are the schools from PSWC or the Pacific Southwest Conference, so California, Arizona, Nevada, and Hawaii. And what this project entails, as I said, is designing the obstacle course, but a design report, more specifically, the proposal to build it, the competition report, and the physical course, which is optional and doesn't count towards PSWC. I don't know where we would build a 100-foot long course, but it's something to think about, I guess. So the course guidelines, as I mentioned before, structures that have to carry people off the ground have to be able to, their capacity needs to be at least 400 pounds. You have to be able to prove that in your calculations. The maximum height of these obstacles is 10 feet off the ground. And it must be, you must be able to physically complete it. And then at least 3 obstacles have to take players off the ground. So you can't avoid it. You got to find something to do, probably monkey bars, or maybe, as you can see in this picture, it looks like that little post or fence thing you can hop over. And it must be safe to race. That's kind of something that they emphasize throughout the rules, that they emphasize safety, but as well as it has to be feasible too. You can't come up with this crazy complex design and not be able to build it, or it being too expensive. And also, they also mentioned that if you want to build it, you can. So remember that it has to be feasible. Okay, so on the left-hand side in the picture here, you can see what the obstacle course is actually supposed to look like, or what they want it to look like. So running vertically, north and south, that's the 100-foot long span. And then you can see that gap 1 is 8 feet long, gap 2 and 3 are both 6 feet long. So you can see that the opening obstacle can be anything. They give you some examples of hurdles and ties. And then also the bottleneck, as I mentioned, is meant to slow you down. So that might be like a, they say right there, like a narrow beam, maybe that you have to walk across. And then the height obstacles, they offer a cargo neckline, a rock wall, or even monkey bars. It'd be very interesting to design a rock wall, and actually figure that out. But those gaps, they're just transition points. So I guess you can catch your breath real quick while you're switching over to the next one. And then they give you the option of using any type of obstacles in the opening or the final section. So the competition report, it was a little hard to understand what they were actually asking for, but from what I understood is that the report is or the competition report in whole contains the design report and your proposal. So that's eventually what I ended up figuring out, actually, because they kind of had it all over the place. So they give you a maximum pages for the table of contents, your proposal, the proposal, general overview of your course, maybe some dimensions, some costs, and then the calculations are in the following section. That'd probably be part of your design report. And again, they really emphasize that 400-pound requirement for the safety. And you also have to use like code. So you have to refer to like ASCE 7 or 716. If you're going to be doing wood, which more than likely is what would be used, you probably have to refer to the NDS, which is the Wood Council code. And you have to be very, I guess, neat and specific, and make sure you show all the numbers and give good explanations. Also, as well, the connections, you have to detail that as well. So that's something that something cool that you need to know, because it's a very applicable thing to learn for structural engineering or construction engineering as well. So with the report, you also need drawings. These drawings need to be drafted in either AutoCAD or Revit. It looks like some of our members do know what Revit is, so it'd actually be pretty cool if we use that. Revit is more, you can model like the actual member itself, so it kind of brings the entire obstacle course to life. Bluebeam is just more for like PDFs and like marking stuff up, so might be able to use that, but if you use any other software, apparently you will be deducted for the drawings, at least. You can use other programs for the calculations. So they want like a site view or a plan view, and then I'm assuming in each obstacle course that you have, probably a section view with the detail of what's going on there. And they get very specific with how they want you to detail all that stuff, so it's very important that you read the rules. The individual obstacles, so they want top, side, front views, and then those connection details, as I said. They want you to actually show how it's going to be connected, like spacing of the nails, the type of connection you're going to use itself. Probably just off the top of my head, but I was thinking Simpson. You'll probably have to go through the catalog and check and look at the connections and see what their capacities are, and how you can apply that to your structure. They don't want any glue or string, which makes sense, obviously. So this is the physical course, doesn't count toward PSWC. As you can see, those pictures are very nice because they're not a part of this presentation. I copied Emily's sustainability presentation. I guess I forgot to change these pictures. But with the physical course, it'll be obviously a supplemental, and looks like you're going to be given an hour to assemble everything. So that's very interesting. I don't know where they would do this. Maybe they have you record it and do it virtually, because since PSWC is going to be virtual this year, I guess that's what they'd be doing. Each team, like they said, 4 players to run the race. No graduate students allowed to run, but they can design and construct. And you also have to sign a liability form, looks like, to do the race. So scoring. So the main categories for the scoring are the overall, how difficult was the design? Did it challenge your classroom knowledge at all? Organization, creativity, all that good stuff. The proposal, the budget analysis, be very detailed with what you're providing, in terms or in reference to cost, and then the design organization. Calculations, clarity, correctness, references, make sure you reference codes and the equations you're using. And then drawings, as I said, I kind of went into that a little bit. They really are emphasizing that you show that how everything is put together. So, and then references, as I mentioned, AutoCAD, Bluebeam, Risa 2D is probably what came to my mind when I was making this presentation on how you can design the obstacle course, because that's probably the most accessible program to everybody. It's free to download. There's a student version, so that's what I'm assuming will probably be used, but that's up to the project manager, whoever that ends up being. Simpson softwares, as well as the manuals or the catalogs, and then the manuals like AC7, NDS. Yeah, I think that is the end of the presentation. If anybody has any questions, Luis or Jocelyn. Jocelyn, I know that you were kind of interested in being taking on like a good role on this team, and you kind of joined late. So if you have any questions, I'll go back and and answer any of them.
Can you please go back?
Yeah,
The
sure.
first ones that I missed.
I think you joined about the third slide.
Yeah, the third slide.
Okay, so this was the first slide. Basically, what this project has you doing is testing your classroom knowledge and basically seeing if you can apply structural design to this obstacle course. The entire length vertically is 100 feet long, and you also have to, if the maximum height of any of the obstacles is 10 feet, and and it has to be able to withstand 400 pounds. You have to be able to prove that in your calculations. And the maximum amount of money that you can spend on building this project, if you choose to, is $500. And then the course guideline I had just mentioned, it has to be able to carry at least 400 pounds, and you must be able to physically complete this obstacle as well. So they do emphasize, like, build something feasible that you can physically construct and race, because as you can see, that is a part of the competition if you choose to do it. 4 people would race it relay style. And I don't know if you saw this slide as well, but that is on the left-hand side, that's the obstacle course itself. So there's the opening obstacle. That one can be whatever you want, which is either a bottleneck or a height obstacle. And then you have a gap, which is a transition period. And then those bottleneck obstacles are like a narrow beam that you maybe have to walk across or something along those lines. And then the height obstacle, and then you have another gap. And then the height obstacle is, they mentioned like a rock, cargo net climb, a rock wall, or even monkey bars, or something else that you come up with. It doesn't have to be this. Remember that they're also scoring you off of creativity as well. So if you come up with something better, more power to you. That's more points for the team. And then the next slide, I think you joined in around here. So what the competition entitles for report wise. So you have your competition report, which has your drawings, your calculations, your details, and your summary of basically what your obstacle course is, why you chose to do what you did, and all that good stuff.
Beautiful presentation, Christopher.
Thank you, Emily.
Yeah. I think this is a great competition to the many people that are in this call. If you are considering being a lead, definitely do it. But keep in mind, there is a lot of technical experience that you will gain from this. So even if you don't feel like you're prepared to do it, it's still going to be good for experience overall.
Yeah, definitely. If you're into construction or structural engineering, so definitely apply right over to that. And then also modeling wise, that's what the industry is moving towards. Revit, especially, a lot more companies are starting to use Revit. It's free to download from Autodesk. You use your CSUN account to sign up for it, and then you get AutoCAD, Revit, and any other Autodesk programs that they have. So it's better to learn it now than maybe in the office one day.
Or bring it to the office. Oh, go ahead, Louis. Sorry.
What was like the programs that you use?
Yeah, let me go back. I have it. Did I put it there?
You mentioned RISA, AutoCAD. Oh, there you go. There's it.
Yeah, right there. I forgot to put Revit, but that is the other one. So AutoCAD. AutoCAD is a drafting program. Helps you draw lines, makes you scale everything out. Bluebeam, it's more for the construction field, where you can mark up drawings, make comments, all that stuff on PDFs. RISA 2D. RISA stands for Rapid Interactive Structural Analysis. So that is basically how you would analyze, or at least the program I would use to analyze, like maybe a beam or anything else that this project might need. Simpson softwares. I think if you do some research on the website itself, Simpson does have like softwares that you can say like, oh, I want to use this connection and it's having this much of a pull-out force being applied to it, will it withstand this pull-out force? And then the program will tell you yes or no, or whatever. And then it kind of suggests for you what connection you should use. And then manuals, that's the ASE 7 and NDS. Those are basically codes that are used in practice. So it tells you what type of loads you need to apply to your structure for it to be safe and all that stuff.
I also put a link to the website that you can get the software from. So if you've never had a chance to check it out, and because you are under the Department of Engineering and Computer Science, you are able to get most of these programs.
Okay.
Yep. But yeah, if nobody else has any more questions, I'll stop the recording.
Like, how would you construct it physically?
I have a question. Oh, sorry.
Yeah, Luis, to construct it physically, if I'm being honest, I do not know. You would have to do it obviously somewhere where you have 100 feet worth of space. I mean, off the top of my head, I would think maybe at CSUN in behind Jacaranda in that parking lot, maybe that span is 100 feet, but then also when it depends on what your obstacle course is. Are you able to, you know, move it around and stuff, or like is it something that you have to embed into the ground? So I just off the top of my head, I don't think on their part it was feasible to say like, oh yeah, construct it, because I don't know where you would construct it unless you design it somehow to build it. But yeah, that would be my answer to that.
For construction, you would have to start off with like an actual budget. So I think part of the project is figuring out your cost analysis, but at the same time, you'd have to figure out, can we actually afford it? Can your student chapter afford it? I'm going to tell you right now, CSUN ASE cannot afford to pay for an obstacle course.
$500.
Yeah, I don't think so. I mean, traditionally every team gets $500, but this is a new event, so we most likely would have had to fundraise for this. But yeah, it would be a lot of figuring out where you'd get your materials, who would be able to construct it with you. Do you trust those people? Have they ever used a hammer before? You know, stuff like that. So it's possible, but you would need your team members to be a part of it, and yeah.
Mm-hmm. Good answer, Emily. A lot more optimistic than mine. And what was your question, Jocelyn?
Would you share these slides with just?
Yeah, I'll share them. I'll make sure to change the picture too.
No, it's beautiful. Keep the aqueduct
The pictures
on there.
are really nice. Reminds me of Palmdale Lake. I don't know if you guys been out there.
I have a couple of times. I don't think I've ever been to a park in Palmdale though, but. All
right, man. Well, thanks for the presentation, Chris.
Thank you for the presentation, Chris.
Thanks for coming, guys. Stop recording.